Good evening. Today we are going to do lecture 16, which is specifically the readings are chapter 19 of Stiglitz and Rosengard. A bit of a background first. If you recall, at the beginning of this module, we discussed this idea that redistributing resources throughout the economy results in a loss of efficiency. In other words, there is a bit of a distortion. This is what we will be touching on. So what we will be looking at in this lecture is the effect of taxes borne by consumers. We will quantify the distortions associated with taxes. We will talk about the effect of tax borne by producers. We will talk about taxation on savings and taxation of labor income. So all taxes affect economic behavior, and the reason why is because they introduce distortions. What they do is, or the nature of taxation is that transfers resources in the form of money to government from individuals. And as a result of that, because individuals are impacted, what this means is that their behavior is impacted in some way. For example, what might happen is that individuals start working or stop working after a specific level of income. Why? Because it makes no sense. They enter a different tax income bracket, and hence it makes no sense to keep on working more because they are charged so much in taxes. So as you can see, there is a distortion in the labor market as a result of taxes. So the idea is that taxes might reduce welfare. And the idea of tax policy, or the basis of tax policy, or an underlying principle, is that taxes should be designed in such a way so as to minimize welfare losses for any given amount of revenue that is raised. For example, let's say that we have, again, our beer market, and we have our consumer Crusoe that consumes beer in this market. And Crusoe can also consume soda and not only beer. And let's say that he has a certain amount of income, and that is represented by this budget constraint here. So you can either spend his money on soda, or he can spend his money on beer, or he can spend his money on a combination of both. Initially, the combination that maximizes his utility by putting him on the highest utility curve possible or attainable is at point E. So this corresponds to the combination of beer and soda that he is consuming. Now let's say that we impose a tax on beer. What is it that happens? Well, essentially beer costs more now. So hence he is able to purchase less of beer. As a result of that, the budget constraint curve rotates inwards. The result is that he is on a lower indifference curve and consumes less beer than he previously did. So what you see here is a distortion. His welfare is lower, and his utility is lower, or at least the utility maximizing point is lower than it would have been had the tax not been imposed. So this is an example of a distortion arising from taxation. We can decompose the effect of a tax into an income and substitution effect, and these are demonstrated in panels A and panels B. So why is it that a tax decreases an individual's consumption of beer? Well, there's two reasons for that. Let's start with the income effect. First of all, the imposition of a tax means that an individual has less money to spend on everything. So they consume less of all goods. This is the so-called income effect. What would happen if we reduced our income? Well, what we would see is a shift of the budget constraint inwards if we reduced our income. So hence, we go from being on this point to this point. In other words, we are now on a lower indifference curve, and we consume less of both sodas and also beers. Next, what we have is we have a substitution effect. So what happens is that beer becomes more expensive. So beers are now substituted away from towards sodas. And this is now represented by a swivel of the budget constraint curve, putting us at our final point on a lower budget constraint curve and on a lower indifference curve. So in short, a leftward shift or an inward shift represents the income effect, and then a rotation resulting in us being on a low indifference curve represents the so-called substitution effect. What is it that determines the size of the substitution effect? Well, it is dependent on how easy it is to substitute away from beer to soda. And this in turn is reflected by the shape of the indifference curve. So for example, if we have angular or L-shaped indifference curves, all that we see is a so-called income effect and no substitution effect. So we simply land up on a lower indifference curve. There is no two-step process that we see in panel A. Next, we are going to look at quantifying the distortions associated with taxes. So what is a lump sum tax? That is what we start off out with. A lump sum tax is an amount that must be paid regardless of what he or she earns. In other words, what the consumer earns. What this does is it reduces income. Therefore, in the presence of a lump sum tax, or specifically the introduction of a lump sum tax, what we see is a downward shift of the budget constraint curve. And the vertical distance between the original budget constraint and the new budget constraint is that amount which corresponds to a lump sum tax. So how do we describe the budget constraint? Well, first of all, we describe it as expenditure on beer and expenditure on all other goods, such that the expenditure on beer is a fraction of the budget that a consumer has. And that budget is determined by income less the lump sum tax, less taxes. Next, what we do is we quantify the distortion associated with a tax. And the way we do that is we determine the deadweight loss using indifference curves. Specifically, we compare two types of taxes. We compare a tax rate, and that was an initial situation where we had an imposition of a tax on beer that resulted in a rotation of the budget constraint. And then second, on the previous slide, what we discussed was an inward shift of the budget constraint curve associated with a lump sum tax. So initially, what is the amount of beer that is consumed? It is determined by the point where the indifference curve is tangent to the budget constraint, which is point E, and this would be that amount of beer that it corresponds to that is consumed. What then happens is that we tax beer and we have an income and substitution effect, and that results in our new budget constraint. Note, we are only taxing beer, we are not taxing all other goods, so hence this is a rotation of the budget constraint inwards. That is what we see here. This point again represents what happens if we adjust it for income associated with an introduction of a tax on beer. And finally, what we then see is ultimately the substitution effect combined with the income effect at this new point here, which is our new equilibrium point. The tax revenue that is raised is this distance here, represented by this distance, which is A to A asterisk. So that is A asterisk here. This is where we see, sorry, I've drawn on that. So this is what gives us the tax revenues. And that is the vertical distance between the before tax budget constraint and the after tax budget constraint. Now, how would the situation differ if we institute a lump sum tax? Well, we're no longer seeing a rotation of the budget constraint. Instead, we are seeing a leftward shift of the budget constraint curve. So what would happen is we would land up at this equilibrium point with a lump sum tax. Note, the revenue is then represented by the distance between this point and that point. In other words, the point between the old budget constraint curve and the new budget constraint curve at the point which it is tangent to the lower indifference curve. Note, if we have an L-shaped indifference curves, then what we see is an identical effect of both lump sum taxes and a tax on beer. And the distance between the old budget constraint and the new budget constraint is what gives us our revenues with a lump sum tax. And also then the revenues with a tax on beer. So note again, what we need to look at is the shape of the indifference curves. Now, how do we measure the deadweight loss? So assume that we institute a lump sum tax that has the same effect on utility and as a tax on beer. The amount that would be then raised corresponds to this distance here. And this is the so-called deadweight loss. Note that the situation differs if we have concave indifference curves versus angular indifference curves. And why is that? Well, because the points, or the equilibrium point, after instituting either tax on beer or a lump sum tax, is exactly the same with these indifference curves. Note that the substitution effect is dependent upon the shape of the indifference curves. And in this instance, we don't see a substitution effect. So hence, we don't see a deadweight loss. So the question that we ask in determining the deadweight loss is, how much would individuals be worse off with a tax on beer than they would have been with a lump sum tax? Of course, these two taxes differ, and the difference between them is then the so-called deadweight loss. Specifically, the extra loss in welfare is the deadweight loss, which is represented by this point here. So note, we have revenue with a tax on beer here if we introduce a percentage tax, and what we have here is a revenue with a lump sum tax. And the difference between these two is what gives us the deadweight loss. How can we represent the deadweight loss using a compensated demand curve? Recall what the compensated demand curve is. It is the demand curve that gives Crusoe's demand for beer, assuming that as the price is lowered, income is being taken away from him in such a way as to leave him on the same indifference curve. So in other words, all that it reflects is the so-called substitution effect. So what happens if we impose a tax of T? Let's say that initially this is the equilibrium point and the quantity consumed is Q2. And then what happens is that the cost to the consumer increases as a result of the imposition of a tax. So the quantity consumed then decreases. So what is the revenue of the tax? Well, the revenue is as follows. It is A, B multiplied by A and D, which is then A, B, C, D. So it is the tax multiplied by the quantity that is consumed when the tax has been imposed, which is Q subscript 1. Then what we do is we subtract from what an individual would be willing to pay to have the tax reduced. In other words, A, E, C, and then D. And from that, what we do is we subtract the tax revenue. And that gives us the so-called deadweight loss. So this is now the amount of the so-called deadweight loss as a result of the introduction of a tax. Think about it this way. What is it that we lose? How much do we lose if we introduce a tax? Well, this is what is lost due to the introduction of a tax. Why? Because consumers now consume less as a result of that. So hence, that is why we quantify that as a deadweight loss. So now that we see that the imposition of a tax results in a deadweight loss, what happens if we increase the tax rate? So let's start at a situation where we have no taxes. So this is the quantity of beer that is demanded at a given price level that corresponds to this point here. What we then do is we impose a tax. So the price faced by the consumer increases. We move along the demand curve. In other words, the quantity demanded decreases and we now arrive at point C. The deadweight loss that is introduced is represented by this triangle, and that corresponds to a tax rate of T. Let's say now that we double the tax rate. Well, what is it that happens? Again, the price increases from our initial price and we move along the compensated demand curve to point C apostrophe. What has happened? Well, the deadweight loss has increased further as a result of the introduction of this tax. However, a doubling of the tax rate has resulted in more than double the original deadweight loss. Indeed, the new deadweight loss is 4 times the initial deadweight loss when we introduced this tax rate. So further increases in taxes result in more than proportional increases in the deadweight loss. Next, we look at another aspect. Specifically, we look at elasticity. How does elasticity impact the deadweight loss associated with the imposition of taxes? So this is an extension from a discussion on taxes, and where the doubling taxes results in a more than proportional increase in the deadweight loss. Well, specifically, what we can see here is an elastic curve, or a more elastic demand curve, implying that consumers react quite strongly to a change in the price level, and a less elastic demand curve, suggesting that consumers are not that sensitive, or at least less sensitive relative to this curve here in terms of their reaction to changes in price levels. What we see is that the imposition of a tax is associated with a greater deadweight loss in case the demand curve is more elastic. So for example, the deadweight loss is this area here for a more elastic demand curve, and it is this area here, specifically B, E, and C, for a less elastic demand curve. Why? Because for a more elastic demand curve, consumers are more responsive to the imposition of a tax because price increases to reflect that tax. Now here what we have is a calculation of the deadweight loss, and what it is dependent upon is the elasticity of demand. This is the elasticity of demand, and that is the formula for calculating it. And the implication of this derivation is that the change in the quantity will be larger the larger the change in the price and the larger the elasticity of demand. So this is essentially what this formula shows. Then what we have is the change in quantity that is dependent upon taxes, a price level, and an elasticity, and the quantity that is consumed at a given price level. And hence, what we can do is we can derive the size of the deadweight loss. Thus, we arrive at the following outcome. We can quantify the dead loss, and what we can also do is we can determine or specify the determinants of the deadweight loss. So first of all, the deadweight loss increases with the square root of the tax rate. So that is what we saw, that as the tax rate increases, what we see is an increase in the deadweight loss. And then also it is dependent upon elasticity and the price level. So hence it increases with the elasticity of the compensated demand curve. Finally, the way we can simplify this whole equation here is by stating it in terms of the tax rate multiplied, or the amount of tax multiplied by the decrease in the quantity, or the change in quantity demanded as a result of the imposition of a tax divided by 2. So this refers to the inelastic compensated demand curve, but the principle remains the same, whether it is an elastic or an inelastic curve. So thus far, what we've assumed is that the supply curve is horizontal. In other words, it is perfectly elastic. And what we saw then in such a situation, the entire burden of a tax falls on consumers. So that is who bears the tax incidence. However, the reality is that most curves are upward sloping, specifically supply curves, that is. So what this means is that part of the burden of any tax on consumption will also fall on producers, and not only on consumers. And the reason why supply curves are upward sloping is because as the price increases, the quantity supplied increases. Now, recall that each price levels firms produce up until the point that the price is equal to the marginal cost. So hence, the marginal cost rises as production increases. And also recall that the area between the supply curve and the price measures the producer surplus, as does the area between the demand curve and the price, which measures consumer surplus. So the producer surplus is just the difference between revenues and total variable costs then. So now what we look at is the deadweight loss from taxing production. So assume initially that the price that is charged by consumers is P, and the quantity that is supplied corresponds to this point here. Now, let's say that we impose a tax, call it T. So what is it that producers now receive? It's the price less the tax. So this is where we are now. Initially, the profits received by the producer would be D, C, and B. So this triangle would represent the profits. Now, with the introduction of taxes, what happens is that profits are represented by D, G, and E. And what happens is that government accrues this much in revenue, which is the tax multiplied by the quantity supplied after applying the tax. However, what we also see is a deadweight loss, and the deadweight loss is given by B, G, and H, which is this triangle here. The reason why we don't include government or tax revenues in the deadweight loss is because these are funds that are reallocated from profits of the supplier to government. So these are government revenues now. It is not money lost. However, the reason why we call this the deadweight loss is because this is a loss to the producer and it is not a gain for government. So how do we calculate deadweight loss that is borne by both consumers and producers, and not only by producers or only by consumers? Let us begin with an initial situation. And the price that is charged is P. And then the corresponding quantity is this quantity, in equilibrium, that is. Now, let's say that we impose a tax, and what we assume is that the price that is paid by consumers is given by this, and the price that is received by suppliers is given by this point. So what we can do is we can decompose the change in market demand into two parts. First of all, we have an income effect. So we start with a normal demand curve and we adjust that for the income effect. So what we see is we see a decrease in the quantity. And that decrease is in this direction, and this is the new quantity that is consumed after adjusting for income. Then what we have to bring into this is a so-called substitution effect. So what happens is that consumers substitute away from the tax good along the compensated demand curve. In other words, we now move upwards to this point, and that corresponds to a lower quantity yet, which is this point here. The deadweight loss that is now experienced by consumers is given by this triangle, whereas the deadweight loss that is now experienced by producers is given by the triangle B, C, and E. The total deadweight loss is the sum of these two triangles, specifically triangle A, B, and D, and B, C, and E. It is the sum of these two triangles. So what we see is an inefficiency that arises as measured by the deadweight loss that is associated with the introduction of a tax. Yes, government does receive revenues, but on the other hand, there is a deadweight loss nevertheless, and that is carried by both consumers and producers if we assume that we have a downward sloping demand curve and an upward sloping supply curve. Now imagine that what we want to do is we want to tax savings. So how do savings work, or how does money work in terms of savings? Well, you have a specific income. What you can choose to do is you can choose to spend on consumption today. So we have one period, or you can choose to spend less and save, and what you receive interest in over a period of time, which means that you can consume more dollars in the next period. So we can define the amount of interest that is earned, or the amount that remains after saving, as 1 plus R multiplied by a given amount that is saved, where R is the interest. So that is our return on giving up $1 of consumption today. So if an individual saves that dollar and deposits in a bank, she gets back at the end of the period the dollar plus the interest that is earned. That is the interest that is earned there. So what is the price of consumption tomorrow relative to consumption today? Well, the way we can represent it is as 1 divided by 1 plus R. Now what we can do is we can also denote the wage that is earned in one period, today, and then also the wage that is earned in the next period as W subscript 0 and W subscript 1 respectively. So how do taxes now impact savings? That is what we proceed on to. So let's assume that now today's wages and next period's wages correspond to point W on our budget constraint curve. And this budget constraint curve represents or tells us how much we can consume today given our income and how much we can consume in the next period if we choose to save. So the individual can either consume this amount of units today if they spend all of their income, or they can consume what they save now plus some kind of return that they earn. Or they can consume a combination of today, and also they can save some money. And that is when we would be on any point along this budget constraint curve. And how much is consumed and how much is saved today is determined by the indifference curve. So in this instance, this is the point, and this is how much is consumed today. But what happens is that some is also saved. And we can have a situation panel A, or the situation that we see in panel A is a situation in which the individual wishes to consume less than his or her wage income in the first period, specifically given by this point here, so that he or she saves the rest, which would correspond to this amount of consumption in the next period if all income is not being consumed currently. And this is the level of savings then. In other words, this is what would be consumed if everything would be spent today, leaving this much to be spent in the next period. But if we increase our savings, what we do is we consume less today, but we can consume more in the next period. Now, let's say that we are in panel B, and in panel B, we have a different indifference curve, or at least in a different position. And specifically, what this indifference curve implies is that this consumer prefers to consume more today rather than in the future. So what this consumer does is they borrow from the future. The result is that instead of consuming at this point here, they now consume at this point, which corresponds to point E and this level of consumption. But of course, if we start here in our initial position and then we borrow from the future, what happens is that we will consume less in the future as a result. Now let's assume that what we decide to do is we decide to tax interest on income. So let's say we are dealing with a consumer that is a saver, and their consumption options are represented by this point here. This is the amount that they are consuming today, and this is the amount that they are going to consume in the future. So they're going to consume more in the future for a given level of income. And how you can see that is that today's income is this, but that does not equate to the level of consumption. Now, there are two effects that happen as always. First of all, what we have is an income effect. So what happens is that we shift back the budget constraint curve. Right? This is the original budget constraint curve, this curve here. This is a new budget constraint after we've adjusted for the drop in income as a result of taxation. So what is it that happens? As you can see at this equilibrium point, what we have is we have a lower level of consumption in the future. Why? Because of taxes. Then what we do is we take into account the substitution effect. So this is the point where we land up. This is where the indifference curve for this consumer, the saver, is now tangent to the after-tax budget constraint. So what we see is that there is a distortion in the second period. Future consumption decreases from this point here, where I'm now using the yellow to circle it, to this point, with the introduction of a tax. And the deadweight loss in this situation is given by E multiplied by F. A similar kind of analysis can be applied to labor supply decisions. So what we do next is we conduct analysis of the decision concerning the numbers of hours worked. Now this of course matters because the idea is that when you start working, after a certain point you pay so much tax that it makes no sense to work anymore. So this is a very relevant form of analysis. So let's assume that a worker has two options. They can either work more or they can consume more leisure. So we treat these as two commodities, leisure and labor hours. Think about the employee's time as a budget. That time can be spent either working to fund consumption, or alternatively it can be spent on not working and only having leisure. So the extremes are consumption. In other words, the employee chooses to work as much as possible and spends this amount of on consumption or the money that is earned. Alternatively, the employee can choose to work nothing and then spend all the time on leisure. But consumption is zero as he or she does not have a wage in order to fund consumption. Now assume that this is the budget constraint, and what the employee can do is they can consume any combination of work, funding consumption, or leisure. But this specific consumer chooses to consume this amount of leisure and this amount of consumption as determined by the point on the indifference curve that is tangent to the budget constraint before a tax is imposed. Now let's say what we do is we impose a 50% wage tax. What this results is it results in a consumption cut by half. Why? Even if a consumer is working, specifically the employee is working, the result is such that they have less money to spend on consumption. 50% is half of income, so hence they can spend 50% less on consumption. So again, we decompose this into an income and substitution effect. So first, what we do is we adjust for a drop in income. So our point of tangency changes from E to E with a cap on it. So that represents our income effect. And then what we see is, or what we do is we adjust for a substitution effect. So consumption becomes more expensive now. So what we do is we now substitute away from consumption towards leisure. So what we see is we see two effects that offset each other. Specifically, we continue to consume the same amount of leisure that we did before the introduction of a tax. However, there is still nevertheless a distortion. It appears that leisure is unchanged, but consumption is now lower as a result of that tax. So hence, as long as there is a substitution effect, there is a distortion as a result of that. Specifically, an income tax is distortionary as long as there is a substitution effect. And that is exactly what we see here.